Use the intermediate value theorem to show that the polynomial function has a real zero between the numbers given. We have f of x, which is equal to 4x squared minus 2x minus 1. And we want to find the following numbers 1 and 2. So we're looking for what is f of 1 and what is f of 2. So first thing is first, according to the intermediate value theorem for polynomials with only real coefficients, if f of 1 and f of 2 have opposite signs, then there exists at least one real zero between x equals 1 and x equals 2. So the first thing we're going to do is find out what is f of 1. So we're going to find out. So we're going to say f of 1, and then we're going to plug it into this function. So this is going to be 4 times 1 squared minus 2 times 1 minus 8. Okay, so what do we get here? So we have f of 1. This is going to equal 4 times 1 squared. So that's 4 times 1 minus 2 times 1 minus 8. So what does this equal? 4 times 1 is 4, minus 2 times 1, which is 2, minus 8. So 4 minus 2 is 2, and then minus 8 gives us negative 6. So we know that f of 1 so far equals negative 6. Okay, now let's find f of 2. So we're going to find f of 2. So f of 2, we're going to plug it into the function. So 4 times 2 squared minus 2 times 2 minus 8. So this is going to equal 4 times 2 squared, which is 4, minus 2 times 2 minus 8, and just following order of operations here. 4 times 4 is 16, minus 2 times 2, which is 4, and then minus 8. 16 minus 4 is 12, minus 8 gives us positive 4. So f of 2 is equal to 4. Okay, now let's go back to the definition. What does the definition say? It says that according to the intermediate value theorem for polynomials with only real coefficients, if f of 1, which is negative 6, and f of 2, which is positive 4, have opposite signs, then there exists at least one real zero between x equals 1 and x equals 2. So because they are opposite signs, then there exists at least one real zero. So we're going to say that there exists at least one real zero. And again, at least one real zero. What that means is there's a zero that crosses the x-axis. But let's go ahead and put our answer in first. So here we said that f of 1 was equal to negative 6. And then we found f of 2 to be positive 4. And then it says choose the correct statement. So we would say since f of 1 and f of 2 are opposite in sign, then there exists at least one real zero between 1 and 2. Let's check A. And there's our answer. Now let's just look at the graph and determine why it is and why it exists. So on Desmos, we're going to go ahead and graph this function. Okay, so I'm going to go ahead and graph this function that we have here. And so we have 4. Okay, and then that's x squared, and that's minus 2x minus 8. Okay, so let's take a look at this value here. Okay, and then let's look at here, and then you can see that there's points here, right? So I'm going to go ahead and then copy this graph. Okay, so now that we have this graph, let's locate those points. Okay, so on this graph, let's locate where x is equal to 1 and where x is equal to 2. So here is where x is equal to 1, and here is where x is equal to 2. Okay, so we know that when x is equal to 1, we know that that gave us an output of -6. So that's 1, -6. And then when x was equal to 2, we know that that gave us 2 and then 4. Okay, so what that tells us is because those outputs are two different signs, there is a real zero. There's at least one real zero that crosses the x-axis. And that's why it's telling us, because those are opposite sides.